Hey guys, Dr. Brown here, and today we're looking at simplifying a quotient derivative, a derivative of a quotient using natural logs. So we promised this in our last section with natural logs that we would take a look at this. So let's dive into it. So, all right, let's get busy on this. All right, we've got y equals x minus 2 squared over the square root of x squared plus 1. And we want to take the derivative of that. Now we know we can use the quotient rule. We can say, well, we have the x squared plus 1 square root of that squared, which would eliminate that radical. So we know we would have that. Then we would have the square root of x squared plus 1. The bottom one times the derivative of the top, which would be 2 times x minus 2. With the 2 minus 1, give me to the 1, then dx, or 1, would be the derivative of the inside, minus then the first one, which is x minus 2 squared, times the derivative of the bottom one, which would be, well, that's the bottom one, which is 1/2. The square root, well, let's leave that out, x squared plus 1 to the minus 1/2 times the derivative of the inside, which is 2x. So all of that's over this. Now we could simplify that. We can do that. We know how to do those things. We would end up with something. Actually, we would end up with x minus 2 times x squared plus 2x plus 2 over x squared plus 1 to the 3/2. That's what you would end up with if you simplified that. Now our goal is to take the natural log and end up with something simpler than that transition. There's many steps in between this and that. Okay, how could we do that? Well, if we took the natural log of both sides of this thing, we would have the natural log of y equals the natural log of x minus 2 squared over square root of, let me get rid of that radical sign, x squared plus 1 to the 1/2. We're taking the natural log of both sides. Now before I continue, I should say, you know, the natural log of y is the integral of dy over y, which would be the integral of y prime over y. It's the derivative of a function over the function. That integral of the derivative over the function. Okay, if you take the derivative of that, if I said I have the integral of y prime over y, and I want to take the derivative of that with respect to y, let's say, the radical sign, or the integration sign, actually just falls off. So you end up with just y prime over y. Okay, keep that in mind as we go forward, because this is what we have right here. That same scenario. We have the integral of y prime over y. That's what the natural log of y is. Okay, so let's simplify the other side here. We have now a quotient, so we have the natural log, remember the rule, of x minus 2 squared minus the natural log of x squared plus 1 to the 1/2. Okay, now I can simplify this even farther. I have now 2 natural log of x minus 2 minus 1/2 natural log of x squared plus 1. And that equals the natural log of y, or the integral of y prime over y. Now then, we're ready to take the derivative of both sides. So I want to take the derivative of this with respect to x. Okay? Of both sides. So again, radical sign drops off, y prime over y equals 2. Now if I'm taking the derivative of natural log of x minus 2, that is the integral of the derivative over the function. Well, if u equals x minus 2, du would be just 1, right? So I would have that integral. The integral drops away if I take the derivative, and I end up with just 1 over x minus 2. So I have 2 times the derivative of this, which would be 1 over x minus 2, minus 1/2. Same scenario here. I have u equals x squared plus 1. du equals 2x. So, which is the integral of that. If I take the derivative, the integral drops away, and I'm left with 2x over x squared plus 1. 2x over x squared plus 1. So obviously these 2's cancel, and I'm left with y. Now, keep in mind, we're trying to find the derivative of y. Y prime is what we're looking for. We have it right here. But I need to multiply y to get it, times all of this. But before I do that, I'm going to get a common denominator here, because I have apples and oranges. So I'm going to move this 2 over the top, make for a little space. So to get a common denominator, I can multiply x squared plus 1, x squared plus 1, multiply that side by 1. This side I'll multiply it by 1, but my 1 will be x minus 2 over x minus 2. So what do we have? We have 2 times x squared plus 1 would be 2x squared plus 2 minus, what do we have here? x squared minus 2x. Now keep in mind this minus all of that, so it's minus this plus that, over x minus 2 times x squared plus 1. Now then, I can multiply that, multiply both sides now by y. That cancels, but what is y? X minus 2 squared divided by x squared plus 1 to the 1/2. All right. Let's simplify here. So 2x squared, well, let me write my x minus 2 squared divided by x minus 2. That one cancels, and this one goes to 1. So I have x minus 2 times 2x squared minus x squared gives me x squared plus 2x plus 2 over x squared plus 1 to the 1/2 times x squared plus 1/2 to the 1, which is what? 2 over 2. So 2 over 2 plus 1 over 2 is 3 over 2. So I have x squared plus 1 to the 3 over 2, which is what we wanted to end up with. So use of natural logs can assist you in greatly simplifying the algebraic rigor that's required. Okay, that's all for now. Study, guys. Why are we doing this? Together we're trying to build a better tomorrow and do that through math. All right, that's all for now. We'll talk to you next time. Thanks.